Bismillah ar-Rahman ar-Rahim. In this video, I'll try to explain how to use Matlab for estimating the water pressure in an earthfall dam. We will estimate the water pressure as a function of lags of that water pressure, and also a function of a water level at the reservoir. We will use ANN at the first step, and then in the next video we will use also multivariate linear regression. So in order to start and in order to use MATLAB for this purpose, we will have an example for that. The example says an earthfall dam shown in figure 1, this one, we have a dam, an earthfall dam, and also we have H at time step T, this H, which is the water level at the reservoir, and also we have a read of the piezometer, which is located here at time step T also. So we have readings H and T and P, pardon, H and P readings. Using these readings, we are going to use ANN within MATLAB to find which M and N is better for estimating the pressure at time T. So pressure at time T is going to be predicted or estimated using as a function of lags of P, like P to T minus 1, PT minus 2, and also as a function of H, which is the water level at the reservoir. So in order to start, but we have to understand the idea of the lags. Now, what do we mean by estimating or forecasting P at time T by using P of T minus 1? That means if we use P pressure at the one previous time step, in order to estimate the pressure one step ahead. Let's say, for example, we are recording the water level every 1 hour. So we will use to estimate the pressure at the current time, we will use one previous hour pressure to predict the pressure at this time. Let me repeat. If we are recording every 1 hour, our records every 1 hour. So we will use one previous hour pressure, the pressure at one previous hour, to predict the pressure at current time. This is the idea of the lags. And also for PT minus 2, we also will use the pressure 2 previous hours. 2 hours ago, the pressure at 2 hours ago, in order to predict the pressure at this time. And we are going to see this in practice by using Excel also. But this is the idea, the general idea of what is the meaning of lags or estimating one step ahead. So in this example, we have the values of P, T, and also H of T. And these two are normalized. These are normalized. This is not the time of what is the meaning of normalized data, but these data are normalized for several reasons. For example, first of all, it is easier for ANN to be trained and also to have consistent values of both two variables, HT and H, pardon, and P. Therefore, normalized is used, widely used in most of modeling using data-driven models such as ANN, AMFIS, linear regression. So normalized is widely used. Therefore, it is, of course, it improves also the performance of the models. Therefore, it's also used. So several reasons. So first of all, we are going to form this equation or this function using Excel. First of all, we take our data. This is our data. We will copy them and take them to Excel to do some logs. First of all, in order we have to mention that in order to have or to decide to identify into which lag I have to consider. Let me explain it like this. This one. The example says which M and which M, which means which lag into which lag we are considering H and P in order to get the best performance or the best estimation of PT. Of course, there are several methods. One of them, which is mostly used, autocorrelation function, or also partial correlation, partial autocorrelation function, and also we can use cross correlation function to identify. But some of the studies criticizing this method as autocorrelation function is a linear function, and the correlation or the relationship between P and H could be, or between PT and PT minus 1 could be nonlinear. So using autocorrelation function could not uh, extract all the information in the relation between these two. Therefore, we can use also what is called sequence of time series. For example, we use several model combinations. In the first model, we use only this one, only PT minus 1 to estimate PT, and in the second one, the second model, we use PT minus 1 and PT minus 2 to predict PT, and of course in every model we are going to calculate what is called the efficiency evaluation criteria, like we will use R square or coefficient of determination, and also we can use what is called RMSE or root mean square error to evaluate the models. In the same thing for the H, we can use, for example, for predicting PT, we can use HT as an input only, or HT minus 1, and also these are sequences of models. Let's consider only P. In the first model, as I said, we use only PT minus 1, and the second PT minus 1 and PT minus 2. In the third one, PT minus 1, PT minus 2, and also PT minus 3. In the third one, pardon, in the third model, and so on. So in every model, we are going to consider one lag, and and for every model, we are calculating evaluation criteria, as I said, R square and RMSE, and from this criteria, we are deciding into which lag we are having highest performance. And this is the second method, which is also used instead of autocorrelation function and partial autocorrelation function, and we are going to see this in practice now in Excel. So let's go to Excel and get our data, which is copied from there. First of all, time step is not needed. We will delete them. We don't need them. And this row also will delete it. So we have HT and PT. Let's consider the first model. The first model is P of T will be predicted as a function of P of T minus 1. So let's consider that. So our PT is going to be predicted as a function of PT minus 1. What do we mean by PT minus 1? As I said, PT minus 1, one previous time step, or what we call it, if, as I said, if we are using hourly data or observation recorded at every 1 hour, we are considering PT minus 1 as 1 hour ago is used to predict one at the current time, to predict the pressure at the current time. To do this in practice, we have this PT. What I've been saying is, we use this value, for example, to predict this one, which is, this is PT minus 1 and this is PT. If we consider this one, this PT, at the current time. And also, if we consider this as Pt of the pressure at the current time, we will use this value to predict this value, which is this one is Pt minus 1. I will write them here. If in case of this is P of t, this will be Pt minus 1. And of course, in case this is a Pt, if this is Pt, of course, I'm just giving an examples. Every value of this will going or will be should be a Pt in a big form. But in order to explain the idea, I'm using this example. If we are considering, for example, this one as a Pt or the pressure at current time, this one is going to be Pt minus 1 or the previous pressure, the pressure at the previous time step, which is can be used in the model to predict Pt. I think the idea now is clear. So let's go and do the inputs and outputs for the ANN. What we are going to do is we are going to prepare a Pt minus 1 and use it as an input. Of course, there's something missing here, which is a function of Pt minus 1 plus there is an error, which is must be considered, of course, because as long as we are using models, there are some uncertainty, so there is an error. So in our, of course, this is going to be between brackets to be something like this: Pt minus 1, Pt of P pressure at T minus 1 plus the error can be used for predicting is a predictor of the Pt. Now we have to prepare our data, which is in ANN. We are going to use Pt minus 1 as an input and Pt as an output, and the model will be trained, and according to that we are going to calculate the R square and RMSE. So how to prepare that, or how to get the Pt minus 1? I will copy this. I'll copy this one to get another copy of it. Then, as I said, this value should be used to predict this value. Therefore, something like this value should be used to predict this value. This one is used to predict this value. Therefore, I will remove this value from here. Now, if we can see, this one becomes Pt minus 1, and this is the Pt. Why? Because this is Pt minus 1, which is this value be used to predict this value. If we look at the original column, this value is used to predict this value. And in this case, we got the Pt, which is going to be the output, and this is the input. Let's now not consider the Ht, only considering these two things. So I will hide this one. This is hide. So our model is going to be, this is the input and this is the output. And I think the idea is clear. This is going to be this one. This value predicting this one. This is Pt minus 1 and this is Pt. And let's have, for an example, let's have Pt minus 2 also. I will use this one and put it here as a Pt minus 1 and also P of T minus 2. So Pt now is a function of Pt minus 1 and Pt minus 2. So how do we prepare that? I will have another column here, cover, and this is, let's say, so now we have pt minus 1 and also pt minus 1. So in pt minus 2, what we have to do, this one should predict this point, not this. If we are going, when we say t minus 1, we said one time or the pressure at one time, one previous time step. When we say pt minus 2, it means p of t minus 2 previous time steps is used as an input to predict the pressure at the current time. Therefore, this is the first time step, and this is second, this is third. So using this value to predict this, this is going to be t minus 2, and this is the current time. If you consider this is as a current time, I will write it here. And I think let's delete this one, and I'll go from the beginning just to get it clear. This is pt, this is pt. If we have this as a p of t, this is going to be of pt minus 1, and this is pt minus 2. So if we consider this as a function, pt1 is used to predict, for example, this one step ahead. pt minus 1 is used to predict one step ahead pressure. And if we use two step ahead or two lags, it's also the same. If I say I have two lags, it means two time steps, two previous time steps is used to predict the current time. Or I can say in another way, I can say I use the current time pressure to predict the pressure at two time steps ahead, which is same. They are same, but it's said in different way. I can predict the current pressure, current time pressure, by using two previous time steps pressure, or I can say it like I use the current time pressure to predict two step ahead pressure, two time step ahead pressure. Like for example, if you take hourly data, I will use the current time pressure to predict 2 hours ahead the pressure 2 hours ahead, using current time pressure to predict 2 hours ahead pressure. I think the idea is clear. Therefore, now I will do the same thing I did for the pt minus 1. I will take this, I will do two columns. This is the first one, and this is the second one. As I said, this value in this, pardon, in this one, this is going to predict this one. And in two steps, going to predict this one. So let's take it in the opposite way. In the opposite way. At the current time, as long as I'm using two steps, first of all, our target or our output, we are going to remove two, as we are going two steps. We are using two steps. We are using these two, deleting them, and in this case, we are deleting only one. I'll explain why. So this is pt minus 1, and this is pt minus 2. So if we look at, this is our original data, if we consider this original data, this value is, if we don't consider this column, this value is going to predict this value, which is two step ahead. These are two step ahead. This one to predict this, which is two step ahead. So this is a two step ahead. If we want to, if we come to this column and this column, this value is going to predict this value, which is one step ahead. which is t minus 1, of course, one step ahead. This value and this value. If we do three, for example, three steps, pt minus 3, if we consider pt minus 3, we are going to do the same thing. We will remove from the target three rows or three observations. The first three observations, of course, by the way, this can be done from this side also, from the end can be done, but as long as we are talking about this, we will consider it from the beginning. And if we see this, of course, this is better, and this can be seen better by the from the zeros, which are these zeros. It's something like this one. This is, let's say, this is the current time. This is the peak of t, or the current pressure at the current time. Can be predicted by this one, which is two previous steps, two steps. Then one step ahead is this one, and two step is this one. So this is pt minus 2. And if we are considering only one step ahead, this one is going to consider auto predict this, which is one step ahead. Therefore, if we look at them at other row, this is predicting 0. As I said, this is 2. And in the second, or pardon, in the if we're using pt minus 1, or one step ahead, this value is predicting this, and also the column, the row is the same thing. This one is predicting this. So this is pt. This is going to be pt minus 1, and this is pt minus 2. So we are preparing our data like this. I'm deleting this. So this is our data. So our function is this one, which can be used, of course, for predicting pt. Let's say, for example, we will consider a second model as a function when we want to predict p of t as a function also of pt minus 1 and p t minus 2. This is the second model, and if you're using this as inputs and pt as an output or target, if you want to consider M3 third model, in which the h to be considered, also we are going to have h, but in this time h of t and not t minus 1. So this is our observed data, and to remind you, we have removed two values from as long as we are considering t minus 2. So we remove two values from p, the first two values of p of t, in order to have this value to predict this value after two steps ahead, to predict two steps ahead, and this for one step ahead. Therefore, this value is the second value here. And this should be the case also in h. As long as we are considering p of t, h as a function of h of t, so we also should remove the second or the two first values of h of t in order to have what? In order to have h p of t predicted by h of t. If we leave it like this one is considered as ht minus 2, because this value is predicting the second value or two steps ahead of p of t. Therefore, this is now, in this case, it is ht minus 2. That is two steps previously. This is two steps previously, as we haven't done anything for ht. Is predicting one This is predicting the second value of P of t, which is this value also in this case. Therefore, using two values from, removing, pardon, two values from h of t, we will have h of t. So this is our inputs which can be considered also, and of course the number of combinations or the number of models which is different combinations can be used according to the user. It can be combined according to the user, but these are our input for these three models, and this is just an example. And of course, all the other models can be done according in the same way by following these steps. So finally, we have got our inputs, and these are our inputs for these three models. For the first model, this is the target and this is the input. For the second model, these are the inputs and this is the target. For the third model, these are the inputs and this is the output. So thank you very much, and we will continue in the next video.